Oh. Okay, so let us get started again. Um, so I think the fixed point multiplication is actually mostly correct. I actually fix a couple of just things off stream. You need to be like a little bit more careful, I think, with um doing shifts and manipulations, but otherwise, I think what we have here is like actually mostly correct. Um, now, um, think for now though, I'm gonna actually go back to the floating point, and the reason being is I found on Wikipedia the actual algorithm that I was interested in implementing, which is based on like perturbation theory, which basically says that um, instead of properly calculating everything, you calculate like the deltas from some point. So what we can do is we can calculate like a fixed point on the CPU with like high precision. And then in the fragment shader, we just calculate the deltas away from that point. And then you can do a little bit of an algorithm for basically calculating the next iteration just based on those delta values instead of based on the um, actual calculation. Um, so yeah, this is here. Let us start by just getting rid of this floating points, this fixed point stuff. I'm a little tempted to keep it around though, so um, technically we don't really need to. Well, I don't think we need to keep it around, but we might come back to it later when we want to do extremely high accuracy. But we will see how this goes first. So let's just delete fixed point everything here. This is still gonna just take a vector. Don't really care about these. Now this scale actually might need to be modified for this other option, but let's just get this working again with the floating point values. This is going to be and then this don't care about. Okay, so that's correct. some of this stuff I'd like to move to the top as like a constant. So constant, delete those two. Constant float. Escape radius is going to be equal to 4. Get rid of that. Get rid of that. This is going to be escape radius. And then these are just going to be multiplications. And then this is going to be back to 2 times xy dot x times xy dot y. Yeah, that's correct. Yeah. Okay. Z magnitude. There's still some x's that need to be deleted. So Z magnitude is fine. We can keep that around. These are floats. And then everything else here looks correct. Besides this, but we can fix this. That wasn't even being used, so that's okay. We'll turn that back on in a second here. Also, we should set the iteration count up here. Iterations is equal to 256. And then in here, okay, so right, so yeah, no, that's correct. What happened here? Oh, oop. Don't cast that to an int. That doesn't help no one. Get rid of this. Fix this one up and probably re-include this. So now we can go back into our nice pixelated junk. That's okay. We knew that was gonna happen because that is how it looks. Now, instead though, so what we want to do now is also supposedly there's like some better algorithms for calculating the color, but I don't want to implement them just yet. Long term, I think what I want to do is probably just have a uniform lookup table for the color and then pre-calculate all the colors on the CPU based on the number of iterations, and then just use the lookup table in the fragment shader. It'll be a little bit better that way, I think. I can also like increase these iterations. Like, I think I was using like 300 before. It's like improve a few things. Okay, so what we want to do now is modify. Let me just see what's going on in this. So what do we do? What do we got here? Um, so let's just add this. Let's just save this shader quickly. HSV conversion function. And sure. Okay, so that is good. And then it's like we were building without optimization enabled, which, well, also don't need this stupid thing. That should be there. I mean, realistically, we don't really need optimization enabled because that's just going to be CPU optimization and has little to do with what's going on in this rendering. But because most of the code, there's basically nothing really going on in this CPU main loop, so that's okay. Kind of want to shut up this boundary thing for now. Kind of annoying. Get rid of that. And just print the FPS. Oops. It's fine. Okay, close that. Close. Okay. That's kind of fun. This is all looking good. Okay, so what do we got going on here now? So I want to open the fragment. Well, what do we need to do from the CPU side? So what we want to do is calculate the center of this rectangle. And maybe, I think we still need to, let us just start by getting the center. So, um, rect center. Return rect r dot top left. Oh, okay, I think it's gotta be a vec2 first of all. v2. Oops. And I please. Oh, okay, I guess this is backwards anyway, so So we got the center of the rect. And then we want to calculate z of n for the center. Um, want to do that. I just want to do the wait, now do we might need to actually pass in a um we might need to pass in a vector of zns. So in the perturbation theory, let's go back down to here. Let's just open a thing. So in perturbation theory, Mandelbrot. Um, okay. So in perturbation theory, Mandelbrot, what we have is that z of n plus 1, so let's call it z of n plus 1, is equal to, okay, so this is just normal Mandelbrot. So z of n squared plus c, whatever c is. Now, if we are only considering values around specifically small value, where Zn is like small in magnitude, which is the case anytime anytime any of these values are small, which is always. So basically, what we can say is that what we want is to say that z of n plus 1 well let's say let us consider epsilon e and delta e. In that case, z of n plus 1 is equal to z of n plus epsilon squared plus c plus delta. So I think I've always just been using c of 0, but that's fine. So we'll just do this derivation anyways with the c here. And this is going to be equal to, let's use spaces for this. This is going to be equal to zn squared plus 2zn epsilon plus epsilon squared plus c plus d delta. Why did I call this delta? And yeah, so or specifically in this case, right, we don't need this part. So from the original equation, and let us just regroup. Zn squared plus c plus 2zn epsilon plus epsilon squared. So this first part is our this first part is our Zn plus 1 originally. So now what do we have? We basically have that so sorry, this is this looking correct? I think so. Perturbation. Yeah, this should be correct. So then okay, so let's call this Zn prime, which is this epsilon one. And then, so this is finally equal to z of Zn n plus 1 plus 2z and e, they probably just spaced this so that it was more readable, plus epsilon squared. So what we can do is pre-compute Z at the center of the screen on the CPU using now doubles, let's say, and we pre-compute however many iterations we want of Z. And then with those pre-computed, all those pre-computed iterations, we can basically just sample those from we can store those all in like a big array on the GPU, and then using those, we can do in the fragment shader, we can just grab those ZNs and then just do this epsilon calculation. And this epsilon calculation, I'm also missing the delta here. So sorry, I dropped my deltas. So epsilon here is just gonna be I don't know if delta like even matters here. What is delta supposed to be? Like epsilon's the distance away from the center point. I don't know. D is away from the zero, I guess. Yeah, so delta would be away from whatever the C value is. But the C value I have just been using 0. So delta is just the center coordinate. And then the epsilon is the that's correct. So delta here, center coordinate, where Zn is calculated on CPU, and then epsilon delta, don't call it delta distances, epsil, yeah, that's a good word, good spelling. Epsilon is the um, coordinates on the screen, like the actual coordinates on the screen. Okay. So, and there's also one other thing we can do. So technically here, I'm still a little confused actually about this epsilon in the I see. So actually epsilon is not that. So epsilon en epsilon should be iterated in the shader. So epsilon n plus 1 is going to be equal to, we're going to define it to be equal to Zn epsilon n plus epsilon n squared. Um, Hello, Blemzowski. I don't know how to pronounce your name. I'm sorry. Um, so no, so like right now we're doing like the normal Mandelbrot calculation and just have the Mandelbrot. But what I want to do is I can post a link in the chat. Um, so basically, once you zoom in, you run out of precision and you just get pixelated garbage. Um, So this pixelated garbage is because there's not enough precision in the floating point values to just represent those points. Um, let me just get this link here. Where are we here? Yeah. Yeah, so this link, perturbation theory and series approximation, we basically want to just pre-compute Zn at the center of the screen using high precision. And then on the GPU where we have low precision, we just want to calculate like some delta values. Yeah, so I want, like my goal with this project is I want to be able to like zoom in very far. Um, we'll see how far it's possible on the GPU. I'm not like an expert at doing these weird high precision calculations, so we'll see how well this will just go. But yeah, we're gonna try. So sorry, what was I saying here? Yeah, so epsilon n plus 1 is 2zn epsilon n plus epsilon n squared plus the original delta, um, which is, we already know what that is. Um, so um, we don't need to. So this v, okay, so how are we deciding? Let us just save this in notes. Um, so first on the CPU, we need to figure out, like, first of all, I don't know if I just have, this arena might need to be made bigger. In which case, well, right now we've got 32K, and let's say the iteration count is gonna stay at 256. 256 times, what will be what will be the center value? So I think it can just be calculated using float. So for the pre-computed reference point, you have to, at least from what I'm reading here, at least from what I understand by reading this, is you need to calculate um all the iterations that you're gonna use. So like in the shader right now, um, we just do like the normal Mandelbrot iterations, up to this iterations count. Um, so we don't want to do this compute. We're not going to do this specific computation anymore. We're just going to compute the epsilon n. Um, but to do that, we just need Zn from, or we need to pre-compute all the Zn, like Zn, Zn plus 1, Zn plus 2, Zn plus blah, 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 all the way up to like iterations. And then we'll just store it in a uniform here. So uniform vec2 uz n, and it will just be whatever this iterations count is. I don't think you can just use variables here because that's not fair. So I just have to make sure that these two are synchronized. That's fine. It could still be 300. It doesn't really matter. Yeah, exactly. So we need to basically pre-compute all of these on the CPU and pass them in, and then let the fragment shader just sample from this array for each iteration. So okay, let's just say that these are floats, which I don't know if that's going to work, but let's just try it first. Um, so then we need 300 times 4 bytes per float times uh, 2 floats. So we only need 2.4 kilobytes. And right now, this arena I have, oops, what am I doing? This arena I have, get arena, is just 32 kilobytes, so it should be okay if we're just using 2.4 kilobytes. We are going to want to, like, well, yeah, let's actually at the start of this loop, we will just pre-allocate that. Let's go up here, and I don't even know if I'm using this epsilon value, but define max iterations, and it's gonna be 300 for now. So then we're gonna pre-save this memory. Back to pointer Zn. It's gonna equal to alloc and memory v2 is the type, and 2 times, well, just size of, sorry, not size of, yeah, 2 times, not 2 times, just max iterations. So we'll pre-allocate that, steal from the arena, and then when we move, we have to recompute that. So every time we move, so basically if delta is greater than 0, delta x or delta y is greater than 0, I think I deleted that function. I don't think I need that right now. Do I? Maybe I do need that function. Is there like a space here? Magnitude v2. v2 vector. Return v dot x times v dot x plus v dot y times v dot y. If magnitude v delta is greater than, what am I typing? This is not code. It's greater than epsilon. We'll actually use that epsilon value. Else well, it doesn't matter. We don't need the else case. Or 332 I equals 0, I less than max iterations. I wonder if I should just add, I think I need an extra. I think I need max iterations plus 1. I need an extra one for well, I need to allocate the extra one as well on the CPU. The reason I need the extra one is because I think if we go up to 300, we still need, so in these notes, we still need, so this Zn plus 1 prime. Oh no, never mind. No, it just needs zn plus 1. We need exactly the same number. So yeah, never mind. We don't need that. I'm wrong. We don't actually need that. But yeah, that is fine. So max iterations I plus plus. So we need to we have v2 z. And z, the center of z is going to be the rectangle center of the current boundary. This is not like any space here. So so we need to calculate so yeah, right. So z, what did I call that? Zn. Yeah, Zn. So Zn of I is equal to like the first one should be equal to 0, right? What are we doing here? Sorry, this, yeah, right. So the 0th one is just the center point. I don't actually need this at all. We just need z and 0 equal to this. I is equal to I1. So then, not I1. This is going to be equal to I mean, technically, we don't need to keep calculating this if we go outside the escape radius, but or do we? I'm not actually sure. Well, anyways, there isn't like enough here that it's gonna matter. So, yeah, I hope so too. Yeah, cool. Yeah, thank you. Thank you for stopping by. I'll see you later. Or hopefully, I'll see you later. um, x is equal to. We'll just do this like same exact algorithm here, basically. So x is equal to z and 0 dot x times, sorry, I minus 1, z and I minus 1 dot x. Y is just y. And then xy is v2. X minus y plus z and 0 dot x. 2 times xy, Oh yeah, sorry, the previous iteration. Usually I don't like doing this, but just for the sake of keeping this on the same line. Excuse me. So this should be good. And then once we've calculated this, we will do a GL uniform to FV. Have to set this up properly, but and we are going to send max iterations, and it's going to be a casting for float 32 pointer of Zn. This is uniform, not unifrom. Uniform. So that is looking good. Just like worrying about, can we just try it, but I don't know, it might be an issue. So let us, I'm gonna fix this as well. This is like getting a little annoying. So the uniforms, let us make a uniform table. Let us do anonymous union. This is a nice C11 feature that is very useful. Well, it's not gonna be anonymous. It'll have a name, uniforms. I32 E, and this is gonna be certain count in a second here, and then a structure of I32s. Structure of I32s, and it's going to be screen dimension, top left, bottom right. And we need this UZN. We need like 4. Let's just do it this way. Now we have 4. And down here, we are going to do a table. Uniform names. Screen. And it's going to be U screen dimension, U ZN, U top left, and U bottom right. And then when we update this in our validate uniforms function, we're going to do for U32I equals 0, I less than an array count macro. Size of A over size of A. Validate array count. Array count GGL contacts. Dot uniforms dot E. I plus plus. Okay, so then what we're gonna do is do this. Is equal to get uniform location PID. It's kind of annoying. Oops. Is equal to what's it called? Uniform names I. I'm gonna delete this. So now we've got all of those, and we only need to care about it where we're setting them. So right, so now in this thing we need to implement our little let's close. Now got like Zn for all of those. If we want to get really fancy later, I can do this in SimD. But for now that's okay. So here just assume this part is still correct, and then this is actually, we're going to rename this to D. And I'm going to delete this nonsense for now. Actually, let's comment this out instead. So I might need it later. I don't know yet. C. I love C style comments. Nested comments are dumb. What? Okay. So now what we need to do is, so epsilon 0 is 0. So flow, not flow, v2 epsilon e is equal to vec2 0. It's not called v2 in here. Vec2, and then we got delta, got E, oops, delta E, got this. So we do the same thing again here. We do int I. This part is going to stay the same. And then in here is where so first we need to do, so E of E now equals, so this would be the E update step. So it'll be 2 times Zn of I. This is for the next E. The next E times the current E plus, this is actually where it gets weird. So what is this E squared? Let's go to this perturbation theory thing. So what is this E squared perturbation from the perturbation theory? Because the E is E like a complex number? I think it has to be. Um, and if it is a complex number, then we can't just do E times E. That doesn't make sense. We have to do the full calculation. Let us do this because I might need to. I'm gonna write a function here. Complex mult result dot x is going to be equal to a dot x times a dot x minus b dot y times b dot y. Result dot y is going to be equal to 2 times a dot x times b dot y uh, sorry, brain dumb. There's no zero value here. So yeah, it's just this. So, oh, in which case also this is all just incorrect. Plus the original delta, which is just still D. Okay, so that's the next E. Now this is assuming this is correct. I don't actually have any idea if this is, I might be doing something wrong here. That's okay. So that's the next E. And then the escape radius is still the escape radius. So sorry, so yeah, we need to calculate the next Z. So this part of the calculation should be like the same. I think we need those floats. well, okay, we have that equation now. So vec2 z and just z, I don't, yeah, vec2 z equals vec2 0. And then, so z is going to be equal to this equation up here. So still this zn plus 1 is like worrying me that I need like an extra. So there is like one feature that I know of GLSL that basically, as far as I'm aware, well, actually that's for textures. Okay, I don't know what happens if you read out of bounds in yeah, I don't know what happens if you read out of bounds in just a normal array in GLSL. If you read out of bounds in a texture, it just gives you 0, but yeah, I don't know about an array, so we'll just do this for now. So then z is going to be equal to u z n of I plus 1 plus 2 times let's be the complex mult 2 times z n I. Oh, and it looks like we actually need this intermediate result. So E next. Um, oh, no, that's not right. Oh yeah, sorry. So weird. Yeah, we just need this. Never mind. We just need this E first. That's exactly what this equation is. This equation is exactly this part of the equation. And then, well, our comparison value here should be, still need those values, which is a bit annoying. Now let us see what is going to happen. I think that part is good. I know that's going to complain about a bunch of junk. Yeah, obviously that's an error because we haven't. Also, this is UZN. Okay, this is not correct yet because why did that like jump like that? Weird. Weird. So we need to recompile the main program. It's gonna complain to me about some nonsense. some of this is not nonsense. Some of this is me being dumb. So that is good. 468. Oh, yeah, why did I just copy this and not actually fix what I was doing? I was supposed to delete this. Right. Let's go back up here and rename some of this stuff. Either I use the anonymous name or I use the don't put this prefix on everything. Oops, what happened there? Why did that like do? So okay, so um right. So it's that doesn't get set until I move the if I try to move the thing, then it's just wrong. So a part of this is not going good. Excuse me. Try to keep this a little bit more readable. Um, yeah, what's going wrong here? I don't know why I typed this like this to begin with, because this is kind of ugly. Um, so here, what we do is we just compute all the ZNs. For the center of the screen. Wait, did I really rebuild that? Did I? Let me think here. So before these are just set, I think they're all equal to 0. So why does this just work then? Hmm. Um, let us, yeah, okay, let us set a breakpoint in there and see what is happening. Blah, blah, blah. Let's move this to a different window. And let's open main.c, scroll down to here, set a breakpoint, run, and then zoom in a little ways, and then do that. And then let's see, so locals, let's watch ZN. Well, ZN moved. So let's delete that one. Okay, whatever. That's fine. So next, so we calculate some values. How do I don't know how to I don't know if you can even do this in GF2. Doesn't really matter though. So this is gonna work. Until that. And then we're gonna send those to the GPU, right? So what is the problem here? Those are all valid. I don't know why I have the clear color saved anymore, to be honest. It's not really useful. Um, that should set the value. Uh, Wait a minute. Is like my equation just wrong? Yeah, it's just wrong. This straight up was not correct because oh no. Oh no. This should be correct. Um let's see here. Where's this Mandelbrot perturbation theory? Um Weird. How do we why is that? So like the in the shader, let's just kill this. Let's go back here. Open up a nice window. Um, so in this equation, yeah, this is correct. Okay, at least it's not like, uh, wait, what? Oh, right. So when we reset, though, there's one problem. First of all, when we reset, the mouse callback. we need to recompute that Zn. Um, gonna put a pointer here. And then move this function. Okay, so let's see. Yeah, so that's like completely wrong, that calculation. So why is that calculation completely like, why does it even work at all? Is what I'm curious about. So when Zn is 0, this is just working this thing. And why on earth would that be? Um, hmm. That looks correct. E, E. One Zn is 0 because I haven't initialized it properly. This works. And the reason that works is because E and D are being set. And this approximation is working. Because then the next iteration. Also, that means we don't need this -1 here. Don't break anything if that is there. So why does that break it? Why? Um, E epsilon n, it has to be a, yeah, of course it has to be complex. There's no way it cannot be complex because it has to be at least a vector 2. So it's got to be complex. Why does this like perturbation method not work properly? Interesting. I don't think this is gonna help you. Um, hmm, hmm. So, what this was. Hmm. Why does this not work? What is the problem? So, not seeing it right now. And compute many points around it in terms of various. First of all, does this it's gonna we can technically do that. We can send in a double back. Um but that won't help us. Hmm. Hmm. So, what is the problem? Why does this get weird when UZN is non-zero? So how does that even work if that's that's a really interesting thing that's going on if that is somehow working. Um so this multiplication result. Okay, so this wouldn't be zero, and then this would be zero, which means that is really strange. So we don't update. Do we update? Yeah, I mean, we do update Z. Sorry, Z's updated. Z is this. This is Z. This is correct. Um, I have no idea what's happening. Oh, I know what's happening. Yeah, we need to I actually don't know if this is like more zoomed in than before. Like, what is happening? Well, I don't know, it's getting reset like that, but okay. See if we can find something. Yeah, so what is happening? Yeah, so this accuracy. So shouldn't this should have been recalculated? I don't know why it didn't get recalculated. Something weird is going on with like this calculation, but we're moving, so that should be recalculating these values. They shouldn't be the same. Oh, okay. Actually, that's part of the problem, yeah. Yeah, I see what the problem is. Okay. Yeah, so there's two problems going on here. Also, I don't know about this. Who knows what this is? I think it matters not at all. Um, we need to set like a threshold for when that should be set versus when. So when we should be using the um this approximate method versus when we should be using the true method. So now I think a lot of this is just like the same code, right? So um if you use approx or it just equals d. So that part is fine, and then e this is yeah, this is just the zero, which before was this. Yeah, so that's just that part. And then this is the current one, and then this, the new Z update in the not using the approximate case is right. that looks good to me. This might need to get fixed. Oh, sorry. So x, y, 0. We're not using approximate case, so this is just d. And this is z. Yeah. Okay, so there's no use of this thing. Use approx. False. So if we zoom into here, okay, so this thing should be, these should be set in that case, and then we set this to true and see if this is actually helping anything. Okay, that is like not even. Oh, it definitely. Well, I guess I was zooming out like too much to just tell you if it was helping or not. Um, yeah, I should fix the C code first, I think. Um, yeah, let's try to fix the C code first. Um, so yeah, right now this is like I should just be using a flag for when the thing needs to be updated. So first, let's also add this boolean before I forget. So in here, we will do another one. Use approximation and use approx. Okay. I need to increase this E up to 5. Then here, how do we determine, based on like the zoom level, we got to decide that. But for now, first we need to we don't want to use this magnitude as the needs update. We want to use like some sort of flag. Um, how should that flag be set? So well, like if we're zooming in, it needs to be updated as well. I mean, I guess technically it doesn't, but um just gonna go to the washroom. There's like two problems I'm just noticing. First of all, um, obviously this isn't the ZN isn't being updated at the appropriate time, possibly. Um, and also it seems like the ZN, the center in the screen, is not correct. And that could also be because of the floating point precision error. As that would make sense because it's if you scroll around, you can find it again. Um, what's the uniform for a bool again? GL uniform bool. What's it called? I think it's just like an int. I think it's just. I think you just use an int instead of uniform bool. Um, oh, um, use approx. Um, one int. Hello, Rod old job. How are you doing? Um, so we are gonna set this to GL context zoom greater than 1,000. I don't know. I'm doing pretty good. I'm just trying to basically extend the zoom range of this thing. So, okay, so that's where zoom's 1,000. That's like nowhere near. It's clearly not. Yeah, it's clearly not high enough zoom. 10,000 maybe. We zoom, zoom, and zoom. This. Let's start printing the zoom again to see what the zoom is. Um, oops. I'm gonna print it more than what is this set to? Okay, so here, what is the zoom here? So we should be using the approximation here. Okay. So actually it's not 10,000. I don't know what happened with the zoom 1,000 being weird. 1,200, 1,300. Let's try that. Are we using the approximation? Wait, what? What is going on with this zoom variable? Is the zoom variable like not getting initialized or something? So here we should be using the zoom, using the approximation here. I have a feeling the zoom is not getting initialized properly, and that's what the problem is. Um, yeah, so zoom can only, does it even get reset? No. Yeah, so, okay. This, when we reset, this needs to get set to 1. Also, at the top of main, this needs to get set to 1. Oops. Well, it's just uninitialized, so... Well, actually, no, never mind. It is technically initialized to 0 because this is like a static variable, but um, we will initialize it to 1, which is what it's supposed to be initialized to. Also, we don't need to build with debug symbols right now. Why did that happen? Why is the approximation... What is going on with the zoom variable? Okay, so here is what? It's got to be over 400. Yeah. Let's go back to 1,000, 1,400 again. Don't think we need that. I think this should be fine. So okay, so okay, so that is okay. So 1,400 is also not high enough, clearly. Um, let's try 3,000, I guess. I don't know. 3,000 might be like too much, but So that's, yeah, that is not. So what is a zoom at this point? It's not 2006. It is maybe 2000 is where the good point is. 2200, 2100, somewhere in there. So let us try this. Okay, so is this the approximate method when we are here? Or are we not zoomed in enough? Um, really up the rate of this printing because it's a little annoying. So we're locked to 60 FPS, so uh, every 5 seconds sounds good. Yeah. This is 700. So what happened to like, why was that at, don't know why this like stretches it like that either, but um let me just check how you are supposed to be setting a bool in GLSL, because maybe I'm doing this wrong. Um, Let us see what is going on, because this doesn't really make any sense to me right now. All right, have a good night. Rodel job, however I'm supposed to pronounce your name. Um, w- Hello? How did we go from 700, from 270 to 700? Am I like doing something dumb? And I'm just noticing I typoed the printf thing, but um, zoom variable is a fun. Don't know why it's being weird. why delta is always between 0 and 1. Um, so yeah, that is correct. Better than using the zoom, maybe I should be using the I should be using like the distance actually. So if magnitude v2, just do this. Do approximation. Magnitude v2 of boundary am I using that somewhere? For dp. Okay. The magnitude of the window thing is greater than, let's do it this way. If the magnitude is less than some small value, have that epsilon, I can try that one. Oops. Oh, okay. So here, that epsilon is too big, but somewhere here there should be still need to fix that calculation as well. The zoom doesn't really matter because that's not really. Let's actually calculate this. The top of the loop. And then we will print this, use approximation. Magnitude is less than this. That is like a good time for that to switch, but it needs to go to the right. It needs to go to the correct. So so the calculation is just like wrong because it's not, for some reason the calculation is not centered where it's supposed to be. Um, the rectangle center let's print the boundary center. Um, B bound center equals rect center GL context dot boundary. And then we will print that on a different line. Center boundary center dot x bound center dot y. Now that one should be, so in this recalculate function, we are saying that is the center point. And then for that center point, we want to calculate all the iterations. All the iterations around that point, which I mean, this should be like all good. I want to spam the console every time I recalculate this to see what this is, but also I don't need this. This can go back to that mixed space, isn't it? Um I don't know if this is even the right thing. So what equation are we using here? Yeah, no, this is the same. Like if I want this to be exactly the same, you just do v2 temporary is equal to this. And then use approximation. D still needs to make its... Or is this the problem? Is D is not supposed to be showing up in here? That is fine. Oops, not using that anymore right now. What is that? That should be fine. So what needs to come into it though? So this like center needs to appear in the equation somehow. It's just like the offset. It's important. Maybe this is just like wrong in the shader. Oops. I don't care about this. 464. So that is gone. So okay. So here, right here, we are now tiny center. I'm gonna edit this fragment shader. So yeah, this might just be wrong. I think maybe this should just always be D. Or I don't know. That's even more wrong. And at least we get that. Okay, so is the shader calculation wrong? also use approximation and set this just in case. Now that's gonna slow stuff down probably, but let's just zoom in so we can make sure that it's working. Okay, so at least we know now that the this thing is, well, yeah. No, that's not right. We need to know if we moved. But that's fine. So come into here. This is supposed to be the center. So let's just comment this out and assume that the center is just hard code this. It's possible that this that's fine. Oh right, but this needs to still be adjusted by the so this still needs to be adjusted by yeah, VF is still necessary here. We need to this needs to be so VF is from 0 to 1. And if we times VF here. Okay, well, yeah, obviously that's wrong. Strangely enough, we are not using the approximation. Just gonna update. It says we're using approximation, but we're not. Oops. Okay, well, let's assume that we are. Let's find where we're not. Oh. No, here. Oh, look. Approximation. So no approximation. Approximation. So here we're using the approximation. Now what if we just force this to not use that. Oops. Is the approximation actually improving anything, is what I want to see. I think it is. Not really. It's the approximation is not really helping anything right now. And it's also not even being calculated correctly. So I think that's because I'm not using high enough precision for those. But if I just pass higher precision to the GPU, I don't know if it does anything useful for me. Hmm. Um, yeah, why is it like if we were off, like way off the zero axis, it's not correct? Why is that? Or is it because delta y becomes too small before delta x? That's possible. Huh. Well, I think I might have to stop for now though today. 'Cause I'm getting like a little bit hungry. Um, so we will go here and we will also re-enable this fun nonsense. But we have to fix this. Just copy this one. Then go back to this. Oh, it's not. Oh, it's like messing up as much now. Oh, weird. That's interesting. Huh. We're not using the approximation yet. Hmm. That's no fun. What happened there? Why did we not? Why did that not? Why does that not work anymore? That kind of sucks. Well, in any case, stop there before we use the approximation. And we can actually what we can do is I can hide this and I can do this. And we will have a look-see at what is going on with the stream. I don't think there's anyone up right now, so thank you all for watching, and I will see you all on the next one. Take care.